Good evening, everyone, and thank you for joining us. I'm Adrienne Ott, faculty member at Carnegie Mellon University's Integrated Innovation Institute. The Integrated Innovation Institute sits at the intersection of engineering, design, and business. We focus on building impactful solutions with real value for real people. With two campus locations, Pittsburgh and Silicon Valley, online programs, and a newly launched undergraduate degree, we offer the best of Carnegie Mellon across disciplines and formats. As the author of a book on digital habits, I'm especially excited about tonight's topic. How are AI embedded products changing the way we think? It's a fascinating area that touches on cognition, behavior, and the future of human-machine interaction. Joining us tonight are two outstanding colleagues from the Integrated Innovation Institute, and I'm so pleased to introduce them. First, we have Dr. Arthur Sugden, who is the founder and CEO of the AI startup Allref. His work bridges neuroscience and AI, including research on attention rhythms during his PhD at Brown University and memory formation at Harvard, where dopamine played a key role. His current work focuses on building AI systems that better align with human cognitive processes. We also have Susanna Zlotnikov, who is an assistant teaching professor and director of the III online program. She's a qualitative design researcher with deep expertise in implementing new technologies into complex, regulated clinical workflows. Her research emphasizes human-centered design in high-stakes environments, ensuring technology enhances, not disrupts, critical care processes. Together, we'll explore tonight how AI is not just changing what we do, but how we think. So now I will turn the floor over to our distinguished presenters, Arthur and Susanna.
Thank you so much. So let's start just by agreeing on what AI is. So, right, we can think of AI, commonly thought of neural networks, as a series of individual small computations. And these computations are a whole lot like the computations done by an individual neuron. This idea of layers exists in our brain the same way it does in a standard neural net. And some astounding things have happened in research um, that show that we see a lot of similarities between how, for example, convolutional neural networks, which are designed to analyze images, how they're similar to the kinds of processing that's done in our brain. So if you look at, for example, the ability of neurons to suppress their neighbors to try to identify edges more effectively, we see that same kind of thing learned by a convolutional neural net. So the neural networks that we use are incredible imitations of the brain, but in some ways they're missing a huge amount. And the best example is loops. So there are loops that make up our brain. Oftentimes neurons go out into another neuron and back in. And so we live kind of constantly balancing between too little, which is known as death, or too much, which is known as epilepsy. And this recurrence is key to us, but very different from the neural networks that we often think about. So when we think about AI, we usually think about large language models as of today. And they're incredibly different in that they're designed only to predict the next syllable. That's it. In contrast, we don't think in syllables or words, but rather we actually think of things in terms of phrases and even sentences, with the one exception of psychopaths. So Robert Hare in 2011 found that psychopaths tend to parse information in smaller chunks. It's one of the reasons why they're thought to be so convincing, but that's a different story. So we can actually create our own imitation of a large language model using only 20 lines of code. And all we need to do is for pairs of words in a training set, just learn the frequency of the words that follow. And if we do that again and again and again, we can do a surprisingly good job if we randomly select from those words to produce language that sounds pretty good. So a large language model is really just this very simple operation scaled up and then approximated. So one way to think of this, in particular transformers, which are the T in GPT, is to think of them like working memory. So, in our working memory, for those of us who are old enough to remember memorizing phone numbers, seven is probably the maximum number of things that we can hold in our working memory. And transformers are really best an approximation of working memory, not real memory. So, when we produce the next syllable, it's as if we're using a massive working memory and then we forget before we try to produce the next syllable every time. But kind of tells you a little bit about their efficiency and why they cost so much. As an example, ChatGPT had to learn on 50 trillion tokens, where a token is somewhere between a syllable and a word. When anyone here who's about 30 years of age, you've learned on about 300 million tokens. So that's something like 3,000-fold less to produce higher quality output. Less generalized, but higher quality output. So ChatGPT also took 50 gigawatt hours to train. And you and I, by the time we reach age 30, it took approximately 25 megawatt hours. So again, the difference in power is pretty dramatic. So if we convert ChatGPT answering a question to calories, we get that about one question is about 12.5 human minutes of time. And that's to say, these tools are incredibly general, but there are some disadvantages to generality, right? Specificity allows you to be more efficient in some ways. So, this is a lot to throw at you, but Susanna, how do you think of this as a service designer?
I think of so many things as a service designer, but I think top of mind, especially as we've talked over the last few weeks about this topic, is that really AI agents are enablers of co-creation. So when I say co-creation, what I mean is enterprises and end users are working together to co-create value. And enterprises, so businesses, organizations, they utilize different things to help create that process of co-creation. And so AI agents are a piece of that and an expensive piece of that. But they are there to help extract value for both end user and enterprise. So if we think of large language models and how we interact with them, such as ChatGPT, there's an interactive layer that is there to facilitate the conversation between the user and the LLM. And so this is an area called conversational UI. Conversational UI is a specialization within UX design that looks at how do we best design the conversations between the offering or the AI agent in this case and the end user. And so a common example is when you go to a website and you're trying to complete a task, add something to your shopping cart, and all of a sudden you get a customer service chatbot. So that is conversational UI. You can talk with it, you can chat with it. Another common example is Amazon Alexa or Google Home. So let's think of ChatGPT as what it is. It's an AI-powered chatbot. And it, along with other large language models, mimic human language. So this is by design. And I'd like to read an excerpt from OpenAI's public launch of ChatGPT in 2022. We've trained a model called ChatGPT, which interacts in a conversational way. The dialogue format makes it possible for ChatGPT to answer follow-up questions, admit its mistakes, challenge incorrect premises, and reject inappropriate requests. Now, I think over the years, we've seen examples where this isn't quite happening at 100%, but this is the goal of ChatGPT. And what stood out to me is it being conversational, it having a dialogue. And so, for example, if I open up ChatGPT and start a prompt, what is interesting to me is how it welcomes me. So it says, where should we begin? So we, me, and them. So the chat GPT. And then as I start to converse with it, so I entered in a pretty simple yet kind of difficult question. So which color is better, green or blue? It responds with, well, that depends by what you mean by better. And it gives me a smile emoji. So it has that feel of like I am chatting with a person. It's casual, it's friendly, and it really does feel like speaking to a human. And so, as a designer, I start to wonder about the implications of making AI agents seem human. So another concept I want to introduce is anthropomorphism. Has existed for thousands of years, but in human computer interaction, anthropomorphism is actually a technique that's used to make experiences feel intuitive and make experiences more persuasive. So an example of that is one of my favorites. I love Duolingo. Duo the owl, Duolingo's mascot, has probably guilt tripped at least some people in the audience. And the caveat here is it is persuasive and does make the experience engaging and intuitive, but the other side of that coin is it manipulative? And does the enterprise really always have my best interest in mind? And this is a convention known as deceptive design. Some refer to it, so if you read papers on this, it'll be referred to as dark patterns. And so these are all things we really need to start to take into consideration when we add this interactive layer on top of a large language model.
And what leads designers to choose anthropomorphism?
Great question. So because anthropomorphism makes the experience more intuitive. So if you think of, talking to a person and using everyday language versus not to insult the engineers, but engineering speak. So language that doesn't feel natural, very technical. Um, Going for the more intuitive leads to a more enjoyable experience and more likely for the experience to be successful in a digital interface.
That makes a lot of sense. And so it's like it adds experience, but you've also called it manipulative. Where do you see ChatGPT as landing?
So also a great question. What's interesting about ChatGPT, and this is starting to come out more and more, is this notion of it being sycophantic. And by that, I mean it uses flattery on top of its anthropomorphic quality. So it's not just talking to a person, it's talking to a person who's constantly flattering you, complimenting you, giving you positive reinforcement, which sounds good, except it could borderline be manipulative because it's misrepresenting how accurate its responses are. And so that kind of leads into dangerous territory, and you keep the person maybe more inclined to keep conversing, keep that dialogue running, and not realizing that they're not actually getting what they need out of it, or they might be offloading way too much onto the agent, being way too trustworthy of the data instead of being thinking critically about the information that they're getting.
That makes sense, and it kind of leads me to think about right, oxytocin as kind of this care hormone, one of the things that we think about, which has direct effects on the brain. It's also a neurotransmitter and can be triggered by kind of these caring conversations. So the sycophancy and the friendliness, the perceived friendliness of, as you pointed out, this anthropomorphized design can definitely affect our brain. Um, One other example, dopamine, right? Everyone knows about dopamine and the reward system, but that's also acts as a neurotransmitter and can affect how we form memory, as an example. I think one of the most interesting parts of how AI affects the brain is in memory. So, right, we've talked before about how neural networks closely imitate how we learn facts. We can think of that as modulating the connection strength between neurons. So that can be short-term plasticity or long-term plasticity. And the weights between neurons in layers of artificial neural networks are extremely similar to these kinds of weights that are learned between neurons. But a fascinating thing and a frustrating thing about our brains is that one of the things that leads us to form memories is effort. So putting in energy tags things as being more valuable to consolidate. One example of how we can tell this is you can actually record the pupil diameter as someone's paying attention, right? Like maybe people can see our pupil diameter right now and tell how much we're paying attention. With a broader pupil, meaning that you're paying more attention. So we can now tell how much cognitive effort are people using when they use these different tools, and we can see that cognitive tasks that require more effort lead to creating memories more efficiently. Um, Memories are fascinating. One way to think of how they're stored is in the hippocampus, which is a seahorse-shaped object in the middle of our brain. I used to call it the card catalog, but many of the people here might not know that phrase. So instead, you can think of it as a barcode system for the brain. So it takes in all of our context, and that is place. You might have heard of place cells, those go in, but also the sights and the smells and the sounds, and they form a barcode to which memories are attached. And those of you who've experienced deja vu, which is probably everyone, if you have a barcode that's similar to a different barcode, that randomly you might trigger a connection with the wrong memory. So that's deja vu. Another fun fact is that when we record memories, we record them in dreams, and that's 10 times faster than being awake. So if you ever wake up and you think a lot of time has passed and it hasn't, that's because your dreams are fast. But anyways, um, so I think, broadly speaking, everyone's scared with new inventions. You and I have talked about the fact that when the printing press came out in the 15th century, people were worried that people would become less studious. And then a century ago, mothers in Arizona were really upset when the radio came out that it would lead to, quote, overstimulating, frightening, and emotionally overwhelming for children. And then naturally, everyone freaked out when Google came out that no one would be able to remember anything. So, right, none of this is to say that AI doing something inherently problematic, but rather it is possible that it's changing things. And in fact, the data suggests that it is. So the first example that's relevant is people compared net savvy individuals in the early 2000s who used Google to those who didn't. And what they found is that the net savvy individuals, when you recorded their brain, seemed to be not necessarily remembering a fact, but rather remembering how to find a fact. So really, we began to offload our memories to the internet. And that's pretty incredible. It means we can all store so much more information. But the minor downside is that we can no longer accurately assess the quality of the information. So it's been demonstrated that those people who've offloaded memories are less good at determining the accuracy of it. We tend to overestimate the accuracy of things we find on the internet. And we have the problem that if the internet goes down, we go down, right? So there's some downsides, but at the same time, we know so much more. Um, so, relatedly, there was a beautiful study that showed that if you take three sets of students and you give them access to only books, to Google in Books, or to ChatGPT Google in Books to do their research, they have to write an essay completely on their own. That even though everyone wrote their essay, those who used ChatGPT remembered what they wrote less well. And those who used Google remembered less well even than those who used books. ChatGPT being the worst, Google the middle, books the best. And that kind of links back to what we discussed before, that effort tags memories for consolidation, for forming long-term memories. So using an LLM can fundamentally lead us to form memories less effectively. So in many cases, that's fine, right? But it's worth knowing that if we really want to remember something, if you are in a class right now, even using ChatGPT to summarize papers rather than doing it yourself might be a little bit of a downside. Okay, again, threw a lot at you, but from an interface perspective, how do you think of this?
So because I'm a researcher and a service designer, I think of interface design and UX design as a piece of a bigger picture and an experience for the person. So interfaces are places where touch points happen, and they happen to be digital. And typically that'll be part of a larger workflow journey to perform a particular task. And so I then think about how what happens as that task repeats over time and how that changes behavior. What are the long-term impacts of that? So I go from here to way out there very quickly. Um, so thinking about the end user's overarching goals, there are trade-offs that we and these users need to calculate when it comes to behavior change or how we change our processes, what you were talking about with offloading memories. So if we're offloading memories and reducing cognitive load in the short term, what does that mean for us in the long term? And so what I really liked about the study that you were just talking about from MIT is that they call this cognitive debt. And I think that's such a great metaphor for thinking about offloading memories. So if we think about financial debt, it's not just the money we don't have, it's the wealth we're not building over time with that money. And I think about that in terms of the memories we're not creating and how those memories no longer exist for us to create new memories, new knowledge. But there's always kind of this push-pull of like, well, we want to reduce cognitive load because that's what the user wants. So we were talking earlier about using Google Maps. So I've made this choice that I would rather use Google Maps and rely on Google Maps than learn the art of navigating, understand how the roadways work in the US. And I'm okay with that. Most of the time it works out in my favor because I've offloaded that memory and that knowledge of this system, but I've gained so much more out of it because I know what traffic's going to be like. I know when I'm going to get somewhere. I know if there's been an accident. There's so many pros to that, but I've made the decision to do that. And so I think that's how we need to think about, what are the trade-offs.
I think that's a great point. And Google Maps is something that pretty rarely goes wrong. I mean, there's a few edge cases where people have driven into a ditch or something, but like I think that's a great example of something where offloading it is effective because it's trustworthy, it's consistent, it likely gives the same responses every time. It can be updated with new information. I think it becomes much more interesting when these tools interact a little more aggressively with our brain. One study that we both know about that's kind of fascinating is from a few months ago, showed that on average, a group of professional programmers who programmed open source software, believed that they were 20% faster when using large language models, but turned out to be 19% slower. And I've spoken with a lot of experts who say, hey, that's 4 months ago. That's an eternity ago. A lot has changed. And I believe it, right? But at the same time, it does show a disconnect between our own perceptions of how AI is helping us with the reality. So I think that says that we should not trust our own brains in these cases, especially when it feels like we're working with another human, collaborating, right? Um, so, relatedly, EEG measurements of people using large language models show that there's decreased cognitive load when we use them. And I think that that is the reason why many of us choose to use them and why it is often good to use them, right? We're like saving energy for something more important. That's valuable. Um, that being said, I think it's worth noting, just from an AI perspective, right, chain of thought reasoning for anyone who uses fancy ChatGPT 5 as it shows you what it's thinking about over each step. Remember that this kind of reasoning is allowing one of these large language models to babble to itself and then create a conclusion. And what it's showing you is not the babbling, but the machine's interpretation of what you would want to see when it's babbling, which is somehow different. So I think that there are a lot of cases in which we use these tools, our natural perceptions don't necessarily align with what's actually happening. So, okay, given that our brains are being a little bit messed with, do you think that we should move away from anthropomorphic design for these kinds of technologies?
I think so. I think there's this risk of as we were talking about earlier with anthropomorphism, it essentially what it's doing is it's making us see human-like qualities that aren't actually there in objects. So when we say, for example, even I do this, oh, ChatGPT is thinking. No, it's not. It's not thinking. It's not a sentient being. It's not a living thing. It's doing what it's programmed to do. It's processing data. But when we start to use these words and pair that with the sycophancy, so the constant flattery, the confidence with which it gives responses, and the speed at which it gives responses, and we've talked about, it will give you a confident response whether or not the data is true, which is actually quite frightening. And I believe you were saying, telling me earlier that the bigger, the more processing that happens, the more likely these LLMs are to hallucinate. So that is scary. And I think in low risk situations, okay, you might get embarrassed or you might miss an error and you get corrected later on. But think about how that erodes trust over time. And so what if the stakes start to get higher? What if we start looking at agentic AI, where we basically hire AI to do things on our behalf? Are we really going to trust it to do that? How many times do we have to be burned before we say, no, this is not something I'm going to use? And one of the examples I was talking about earlier is, in healthcare, you have to earn trust. It's not inherently there. There's a lot of apprehension around introducing AI technology into workflows where it starts to make decisions or recommendations instead of the clinician. So there's so much work to be done around building that trust and putting these safety layers into these workflows. But it's not the same when we're talking about, general day-to-day use. If I'm submitting an essay that's due tomorrow and I need 5 pages, yes, grades are on the line, but it's not lives on the line.
Okay, so I hear you saying, right, like that trustworthiness is a key component of what needs to be considered in any use case. And if we can push these models to be in more trustworthy regimes, then we get a huge advantage. Um, I think that that's really interesting. If we think of the space of the answers that any model can give, if you ask open-ended questions, you are allowing the model to draw from anywhere in its training set. So it will naturally draw from Reddit or YouTube comments just as much as it might from some academic publication. I think we can be clever. This won't solve the hallucination problem necessarily, but we can be clever to push large language models to draw from the correct training set in how we phrase questions, or by giving them data that they should summarize, for example.
Hmm. But that takes knowledge of what's good data and what's bad data, right?
That's true. That's true. I think right. I mean, it, from everything you're saying, the more we step back and think of these as tools, as like a tool in our tool belt that we can build off of, clearly, I think the better it is. The more we can separate ourselves emotionally from these tools and acknowledge that they are incredibly fancy and unusual search engines that don't necessarily give you the same answer every time, right?
Hmm.
Yeah,
Right.
that's really interesting. So, how do you think, how can we, if we're designing new systems, how can we push them into a regime that provides value for users and for enterprises?
So drawing from service design principles, I tend to think a lot about the DART model. So this is, a framework introduced by the authors who talked about co-creation. And it's basically mechanisms to establish collaboration between an end user and an enterprise. So DART is dialogue, access, risk assessment, transparency. And I feel like this is becoming so much like increasingly applicable as these AI solutions become more prevalent and more complex. And so if we start to see end users as partners and collaborators rather than just people trying to accomplish a task. And we realize, okay, we need more transparency. We need to equip end users to really like be able to assess risk so that they make the decision of whether or not this is an appropriate tool or way to solve their problem at hand. I think there's, more that we can do in terms of dialogue. So how we say, no, this isn't good data. This, instead of the thumbs up, thumbs down, we can make more robust interactions around that. But really, like to me, it comes down to transparency. Like, what are these generative AI tools capable of? And more importantly, what are they not capable of? And really encourage people to understand those things.
I think that points to one of the really natural mistakes that people make, which is to ask an LLM, why did you get that wrong? Or why did you answer it that way? Which is such a human question to ask. But right, ChatGPT is what's known as a mixture of experts model. So it actually draws from one of 8 or 16 separate submodels for every individual syllable or word. And in fact, an answer can be made up of responses from many different models. So, like, naturally, it's literally impossible for this tool to be introspective, for it to know how it created the answer and how it got it wrong, but rather it's trying to give you the answer that would most please a human who was used to train how it answers questions. Like that I think is both confusing and informative for how we can use it.
That's like such a good way of putting it because it's like just the idea of different models answering the question and handing off the conversation already is like, okay, we already should not think of this as one person
Yes, yes.
because it's not.
Yeah, I think imagining it more of a chorus of Furbies or something like that might be the
Yeah.
best way to think of it. I mean, all of
Yes.
this said, right? My day job is in part based around using these tools, and so I believe that they're immensely powerful when harnessed in specific ways. So selfishly, I would say they're extraordinary for being a thesaurus. What's that word that means that thing that starts with a P, but maybe it doesn't? Incredible. But more interestingly, what are all of the terms that someone might use to try to search for this particular topic? I think these tools are incredible at for for imagining that you're a person, so drawing from information. For example, if you want to practice job interview, I'll bet you'll get a better practice job interview from ChatGPT than from many others because it can draw from real questions. And
Mhm.
then to act in summarizing data. So as we said before, if you can mathematically, you can push your answers or skew your answers towards the style of answers that you want, particularly if you can prime an answer with real data, then the chance that you get something that's trustworthy is extraordinarily high.
Mhm. Yeah, I think that's great. I mean, it's just going back to what you were saying earlier about, how Google changed our brain. So we've learned how to retrieve information, not necessarily remember information. And this is taking it to the next level. It's not just retrieving information, but I think to get to like the optimal output, it's learning how to assess the information and kind of tweak the prompts, understand how to ask really good questions, and think like have that critical lens when we're looking at data. I think that's going to be such an important skill, and it's a great skill to have.
Yeah. And so we'll continue talking, but for anyone in the audience, please jump in and ask some questions. We'll answer our first question, which is, are there generative AI tools that are able to estimate and communicate the level of confidence in the given response? Um, Maybe I'm missing something, but the research actually says that, to my knowledge, the answer cannot be yes, that it must be no, that these tools are not able to assess their own certainty as of today. That being said, this is just one type of model. Large language models are the fancy model of today. They were invented in 2018 by Google, and OpenAI took them and ran. But that doesn't mean that the weaknesses of this type of model will be true for the models of tomorrow. We have another question, which is how should we think about the future of LLM training data not becoming an echo chamber as more and more online content becomes artificially generated and presumably training future LLM versions? Oh man.
Such a good question.
Do you have thoughts?
I'm going to let you answer that
Okay.
question, Arthur. I know we've talked about this in the past a lot.
I'm excited and also a little bit nervous for what's coming. So if you look at all of the big generative AI companies, their big things are pushing towards video for a training set, pushing towards audio, and pushing towards private data. And that makes a lot of sense, right? Basically, already these companies have absorbed somewhere between 10 and 20 or 30% of all text on the internet. And they've carefully chosen the best text. So they're running out of good text. That does say that we should be hitting a plateau unless there's a change in architecture. Uh, we've hit a plateau, largely speaking. So they're going to be siphoning up private data. So anytime you sign up for a new service, double check. I would not give deeply personal information to a free version of ChatGPT. If it's deeply personal, pay and then block it from training on your data. But so the answer is movies have high information density, private data. And so we should keep an eye out on that.
All right, next question. I'm going to take this next question. How do you feel about AI images and art impacting advertising and how people interpret art? So how do I personally feel as a creative? So I'm not a marketing expert. So I just want to throw out the caveat of that. So I can't speak as much to advertising, but I will say, thinking about art and what it means to create art, when the it's so interesting because AI images are built off of other people's art. And so inherently there's something that feels icky about it, and uncomfortable. But we also think about like, how artists are inspired by other artists' work all the time. But it's also like just giving that credit and paying respect to the people creating art. And then another thing that kind of doesn't sit well with me is how we use AI, the ability to generate AI imagery for art, for advertising, for marketing, instead of hiring someone who's skilled and professional and can understand the nuances of what these images mean, how people experience them. And so there's like this term that's being used a lot, slop, like AI slop. And, there's just this off-putting feeling when a company has decided, so very personal, take the easy way out, or, just throw something into ChatGPT, generate images and use that. Doesn't sit great with me. That's not to say that there isn't a creative way to generate art using AI, but I think that should celebrate and work with creative people, not use their work.
That makes a lot of sense. Um, that makes me feel a little bit better about art. Yeah.
Yeah.
We have another question, which is on the discussion of cognitive offloading. Do you think it's still important for people to learn using the old ways? Or is it productive to incorporate AI? I think that's an amazing question. So
Mm-hmm.
we know that people who handwrite notes consolidate memories more effectively than people who type them because there's a processing step. So fundamentally, if you want to remember things, you must put in effort. The sad truth of being a human is that difficulty is key to our success. So I think the answer is we must use old ways. But as we've talked about, right, there are incredibly powerful ways to use art. We can be creative and use generative AI in combination with our own creativity. We can also use it for things like thesaurus, predicting what an average, some average interviewer might say, et cetera, that are super powerful. So it seems to me that combining the old ways of learning, and then learning how to treat these things as tools. How do you maximize the output of the tool, but how do you insulate yourself from thinking of it as a human? That would be my optimal combination.
Can I just, this is at my desk right
Love
now.
it. Same here.
Writing notes. Yes. So I will say when I read that question, the immediate thought that came to mind, the memory that came to mind is sitting in my school library, pulling an encyclopedia off the shelf, opening it up, and oh my gosh, I do not want to go back to that. That's my limit. I do not want to go back to that. But I do agree with you, Arthur, that there is like this, there's so much value into like really digging into literature, reading, writing. I think sometimes we think about like writing as we need to get to the output. That's the end goal, but it's actually not. It's like the writing is the thinking that happens and consolidating your knowledge into a formed thought. And so I think there's this like, we want to run away from the effort of doing that. Writing is so hard. It is so hard. I know I don't sugarcoat it for my students, but it's that the effort is so important there. We get so much out of it.
That makes sense.
Oh, there's so many good questions. Do you believe, I want to answer this one first. Oh, meaning you, Arthur, do you believe that we are nearing AGI? And when AGI does come around, how will it impact us? And just in case there's some people in the audience that don't know what AGI stands for, can you share the acronym?
Yeah. So it stands for Artificial General Intelligence. And here, I perhaps might have overly strong feelings, but it's a buzzword. Right. There is no evidence to suggest that large language models can process information out of their training set. In fact, some large language models have been trained intentionally leaving out specific kinds of problems, and they fail catastrophically at those problems. So that shows that large language models fundamentally are not generalizing. They just happen to draw from a very large training set. Those are two very different things. Humans are extraordinarily good at generalizing. Large language models are not. The people who are talking about AGI tend to be the same groups who use only one architecture of neural network, specifically the large language model architecture. Um, so I don't believe that they effectively replicate anything like AGI. If you want to look towards the exciting new models, keep track of Google DeepMind. They happen to be pushing the limits with, for example, AlphaFold, which does protein folding, in how you can structure neural networks. I think that's where a lot of the next steps will be. But I also think, right, remember, ChatGPT took 3,000 times more information to become less good than someone who gets a PhD in a topic. Now, it's true that we have many people with many unique PhDs, but the point is that generalizing is fundamentally energy expensive. So you'll never be able to perform as well as a specific model. So I think AGI, it just largely doesn't make sense as a concept, at least for the next 5 or 10 years. After that, who knows?
Yeah, I mean, I would, from what I saw in like embedding AI into like clinical workflows, I mean, each clinical workflow is so complex and requires just certain types of information, certain types of data. It's just so hard for me to envision that there would be like this master AGI that would be able to address all of those things. Um, so yeah, we'll see in
We're all
five to
safe
10
for a little
years.
while.
Was for a little while. 5 to 10 years feels like, okay, I can think about other things in the meantime. Oh my gosh, so many great questions. Do you want to pick the next one, Arthur?
Uh, sure. I mean, the broadest question, can and how can AI be used to improve the way we think? It's so broad, but what do you think? What's your takeaway? How do we basically use it to benefit ourselves?
I think one thing that you talked about is like role playing. So like if I'm practicing for an interview, I thought that was such a great example because it's drawing from like subjective data, but interviewing for a job is very subjective. So being able to practice back and forth, and it's the idea here is practice. There's work, there's effort that you're putting in. And so the ability to think through things more, or like using it to prod holes into your argument. So like as a thinking partner almost, even though, as I said earlier, it's not thinking, but a partner to kind of go back and forth with, to like ask new questions, think of new things, in addition to all the other work that you have to do. So that's how I think about it.
I think that's awesome. And I want to say like I often think of this mathematically. So what is a tool that has averaged together much of the information on the internet good at? I think the answer is representing many different examples of an average. That goes back to the thesaurus idea, but I think more broadly, representing examples. I think taking large amounts of information and making it shorter. You are losing information, but if you need something quickly, amazing. Um, Combing through information, so long as you don't want, uh, as long as you don't want all of the answers, which Google gives, all of the pages, but you want one example, it's incredible. But I think those ideas, those like mathematical concepts can be generalized. Where should we go next?
Um, Lots of good questions. I'm gonna ask the one that, or I'm gonna pick the one that's a little bit provocative and maybe controversial. So how can there possibly be a positive reason for AI use like deep fakes?
I think I don't want to defend deepfakes. I think I think what this points to is something that is deep about AI. And that is, why do these AI systems, why did generative AI start with images and text? And the answer is not the most value comes from those things. I mean, I think most of us here would buy a washing machine that also dries and folds the laundry. Like, I want that. Did I immediately want something that talked like me? Not as much. It doesn't mean it's bad, but it does mean that the easiest solutions are the things for which there's the most data, just fundamentally from like a data science perspective. So we started with the things with the most data. Deepfakes happened to be in there. So there are accidental offshoots that can be very negative or very positive. But if we think about generative AI, we started where there was the most data.
Hmm. There was an interesting use case. I attended a training in terms of how to incorporate generative AI into teaching. And essentially you can create like a talking avatar of yourself. It mimics your voice and your appearance. It moves like you. And it seems like such an like a random use case, but if you're for some reason unable to attend class or like teach a class, you can use your teeth as a stand-in. I'm like, that is a very, very specific use case, just positive. I don't know if
Yeah,
that
yeah.
would be my first choice. Um, okay, we have a lot of questions and only 10 minutes left. And I think our plan is, we will have a collection of these questions, and hopefully, even if we don't get to all of them in the webinar, we will try to respond in some way, whether it's an article or a follow-up webinar, because I'm loving all of these questions.
Yeah, I'd actually love to ask you, what ways could AI companies make their chatbots less anthropomorphic to help people distinguish them as machines and not people?
So don't give them human names for one. That's one. And not that that's really happening currently, but like, if we have an Alexa with a female voice, all right, we can tone it down. Um, Being careful about the words that we use. So I gave the example earlier about ChatGPT saying like thinking, like as it's processing information, it'll write on the screen thinking. Google Gemini does not do that. So it actually, if you start, and you've recommended this in the past, and I really love this advice, but if you do use LLMs, and we're not saying you shouldn't or you should, but if you start to incorporate it more, use different ones. Don't just stick with ChatGPT and don't just stick with Google Gemini. Try to use a lot of them. So Google Gemini does not sound as human as ChatGPT. So um, it's not as sycophantic, so it's not as flattering. It doesn't use emojis like ChatGPT does. To me, what's interesting, so like with how I interact with it, so I use it as I put in a prompt, I write it out, I read what it says, I write a response back. And that mimics how I talk with my friends, colleagues, students, in these chat interfaces. So just using just interface design on top of conversational UI to like make it feel less human. Maybe tone it down on the emojis. Don't compliment me every time I respond back. That would be good.
There's one interesting study that was done that showed that people who were even skeptics of Gen AI, when they had their first conversation, they switched to using please and thank you much more often, which shows, right. And I think a lot of us do it. In many ways, it's good that we do it so that we don't accidentally not say please to a human. But I can say that every time I say please to one of these large language models, I check myself and I use that as a step to remind myself that they're not human. I continue to say please. I sometimes thank them for a good answer. I like to think that I'm pushing it mathematically towards giving it a reward. Another fun fact, turns out this is in ChatGPT 3.5. I don't know if it's true in ChatGPT 5. If you said, I'll give you $200 if you give me the right answer, on average, you got the right answer more often. So even absolutely made up rewards actually promoted these models to give you a better answer. So treating them as human is good, but reminding yourself they're not.
Hmm. Yeah, I'm starting to skim through some more of the questions. Oh, uh, tough one from Kevin that I think we should talk about it. I don't know if we'll be able to give like a full answer, but as AI becomes more prevalent, how do you think it will affect the next generation compared to people who have grown up using books or the internet to learn?
That's a great question. I mean, right, we've seen that people who are uh, net savvy, right, as it was described back in the 2000s, change the way they consolidated memories. I think we will continue to offload forms of processing to these models. One lovely finding in children who use Alexa is that children were particularly good at seeing Amazon Alexa as neither human nor completely machine.
Mm,
So they ascribed some emotional characteristics to it, but not the same as a human. And I think that that's a powerful example that people who begin with these tools are actually a little bit less tricked than those who started, like got them partway through their working life, for example. So I actually think we're going to get a lot better at dealing with them,
hmm.
or someone else will. I won't.
Yeah. Yeah, and I think, Eberly, which, the Resources Center at CMU, so faculty can go there and kind of get feedback on teaching, etc. But they also do a lot of research, and they're doing more research on how generative AI is affecting learning at, the university level. And so that's why I'm saying, like, I don't have an immediate answer for this. And we can predict, project, think about what could happen, but there is research that's going to have to be done to understand how these things are affecting us.
That's great.
The next one on this list, again, I just want to acknowledge it because it's such an important thing to think about, and I want to think about it some more, but I just want to read it out. So, do you think improving education will help limit AI over dependence. Discussion about the difficulty of writing reminds me of high rates of low literacy and illiteracy, 20%, and struggle in American education. Whew, that's a big one. Yes, I mean, so much to be desired in how we educate at all levels. But literacy, yeah, up there. You know, we need to really think about how we're going to educate the next generation of learners and what that looks like. And I think it comes down to is like when we start teaching these tools in school. So again, when I was in school, we had computer class and we were learning how to type, and the skills we were learning were reflective of the technology that was available to us. I hope that we're starting to do that same thing, you know, helping young learners work with these tools in the spirit of successful learning rather than avoiding effort.
I think that's even related to the next answer, the next question, which is, does using these tools, for example, as a thesaurus, lead to dependence? And I think that that's a fascinating question, but I think it is in part because AI feels so tricky, right? It feels like a human. Using fire led to a dependence on cooked food, right? But that's not bad. It meant that we had to be more, we were less mobile as humans, but we had fire. So I think we should just think of this as a tool in our tool belt. We are dependent to some degree on Google and search tools to find information more effectively. I think that's okay so long as we handle it from, for example, a dopamine perspective. We don't get addicted to it. That I want to let you answer if there are any other questions, but this is a perfect lead in for me for a couple final points. So, okay, so
Yes, please.
I think that there are some evidence supported takeaways that I see from the brain side. The first is that I don't think we should be scared of LLMs. We were scared of the printing press, we were scared of radio, we were scared of Google. They were all okay. I don't think we need to be scared. But as these tools become more complicated, we need to be more careful in regulating how we use them. Similar to physical exercise, intellectual exercise takes effort, right? Like, if you got to put in more energy physically, you have to do the same intellectually. We should just see it as exercise. There are times when you don't exercise, there are times when you do. LLMs are powerful, they have weaknesses. We have highlighted their strengths and weaknesses here, strengths being thesaurus, summarization, role play, taking information from the average of people. But I think that more broadly, if we think about AI, this is just the popular model of the day. Google depends on similarity AI models of a different type, and the next model will do something different. So we just have to continue to take these rules and then apply them to each new model. Last thing is don't trust your instincts with LLMs. We get tricked, right? People assume they're better with them. You might not be. People trying to ask them why they got it wrong. You can't. So don't trust your instincts. Rather, test things out, play with them, and find the use cases for which you trust them as a tool.
Those are great, Arthur. Thank you. And just my two takeaways from this, what I hope you'll carry forward in the audience is, if you're working in product, treat your end users as collaborators and partners. Talk to your customers, please. Learn about your customers, understand what they're trying to accomplish and what their bigger goals are. And if you're a customer using LLMs, please do, nothing wrong with that. Just start thinking about like, what are you exchanging for those short-term wins? If you're taking, let's call them shortcuts, or if you're using the less effortful approach, what are you trading off for that? And I think those are some good things to just keep in the back of your mind as these become more prevalent in our day-to-day lives.